This is our second day in 2.4, and we're going to be focusing on completing the square. Now, so far, we have learned how to solve quadratic equations by graphing and by factoring. And I'm just going to read this little note right here. It says, in 2.3, you learned how to solve quadratic equations by factoring. Remember, that's when we would factor and then set equal to 0. However, many quadratic equations, such as x squared plus 10x minus 3 equals 0, contain expressions that cannot be factored. So that was actually the warm-up from yesterday's notes. Remember, we said there was no way that the factors of 3 could give us the middle term of 10. So we just said not factorable. We didn't solve for anything. Okay, well, just because it's not factorable doesn't mean that we can't actually solve it by completing the square. In fact, and this is really important, so I'm going to star this, completing the square is a method that lets you solve any quadratic equation at all. Okay? So let's go ahead and actually solve the equation that we had previously stated was not factorable and we couldn't solve for before. Before I do that, I just want to, I'm going to write it up top, remind you what we did for completing the square. It was on our notes from yesterday as well. Remember, we talked about the history, and then I described the basic process, and we tried a few examples. So the first thing we have to do when completing the square is we need to get it in the form x squared plus bx. And we're going to add some number. In order to find what number we should be adding in order to make it a perfect square binomial is b over 2 squared. When we add this number, b over 2 squared, like I said, we're going to end up getting a perfect square binomial. And that would look like x plus b over 2 being squared. So essentially we're taking what was inside of the parentheses, what we ended up squaring, and putting it here. Okay, let's see how we can use this to actually solve, because all we've done so far is rewrite it, and I'll show you the notes from yesterday. All we did so far was rewrite it as a binomial. We didn't actually solve for anything. That's what today's notes is focusing on. So starting with example 1, the first thing that I need to do, remember it says it right up here, the first thing I need to do is get it in the form x squared plus bx plus some number. And right now I have x squared plus 10x minus 3. So I need to move this 3 to the other side, making the left-hand side in that form that I want. So in order to move the 3 over, we need to do the opposite. I'm currently subtracting 3, which means now I have to add 3 to each side, because what you do to one side, you have to do to the other. I have x squared plus 10x equals 3. Now, we need to add some number in order to rewrite it as a perfect square binomial. But like I said, what you do to one side, you have to do to the other. So if I'm adding some number here, I need to add some number over here. The number that we're adding is b over 2 being squared. B is the number that's in front of the x, so I have 10 over 2 squared, which is 5 squared, or 25. I'm just going to go ahead and rewrite it now that I'm plugging 25 into those spaces. So I have x squared plus 10x plus 25 equals 3 plus 25. I can now rewrite this as a perfect square binomial, and that binomial would look like this. X plus 5, it's a positive 5 because this was a positive 5 here, being squared, equals 3 plus 25 is 28. Now, using the square root property, we need to solve for x. So the thing that's being squared is already by itself. So I can go ahead and take the square root of each side. Remember, every single time we take the square root, we need to put a plus or minus. So I have x plus 5, because the squared square root cancel out, equals plus or minus the square root of 28. X is still not by itself, though, and that's what we're trying to do. So I need to get the 5 over to the other side. I'm currently adding 5, so I need to subtract 5. So I have x equals, you cannot combine the radical and the whole number, so I have minus 5, so negative 5, plus or minus the square root of 28. Now, I'm not done yet. Even though x is by itself, I still need to simplify the radical if I can. So if I think about the factors of 28 that are perfect squares other than 1, I know that I can rewrite it as, I'll do it over here. The square root of 28 can be rewritten as, let's see, I think 4 times 7. There we go. Using product property, I can split it up. So square root of 4 times the square root of 7. The square root of 4 was 2. Square root of 7 is 7. Let's just make sure that I've simplified it all the way. So I need to take a look at the 7. The factors of 7 are 1 and 7. And none of those are perfect squares other than 1. So yes, it is simplified all the way. Meaning my final answer is negative 5 plus or minus 2 square root of 7. That plus or minus means that really I have 2 solutions. One of my solutions is negative 5 plus 2 root 7, and then the second solution is negative 5 minus 2 root 7. These are exact answers. I do not want you plugging it in and giving me a decimal approximation unless I specifically ask you to, and as of right now, that is not what I want you to do. Let's try it again. I feel like practice and repetition is the best way that we're going to get this method down. So, first step, I need to get my equation in the form x squared plus bx. So I need to move the 20 over to the other side. That gives me x squared plus 8x. I'm going to be adding some number, remember, equals 20. And I'm adding some number. That number that I need to add is b over 2 being squared. B is a positive 8, so I have a positive 8 over 2 being squared. That's 4 squared, or 16. I'm going to rewrite it now that I'm plugging it in. So x squared plus 8x plus 16 equals 20 plus 16. This is now a perfect square binomial of x. And then I look here, my b over 2 was a positive 4, so plus 4 being squared equals 36. We need to solve for x, so this is where I use the square root property. So I take the square root of each side. That gives me x plus 4 because the square and square root cancel out. Equals plus or minus, because every time I take the square root, I have plus or minus. The square root of 36, well, 36 is a perfect square of 6. X still isn't by itself. I need to subtract 4 from each side. So I have x equals negative 4 plus or minus 6. Now, before, in number 1, I couldn't combine these because this one had a radical and this one was a whole number. Here, I have 2 whole numbers, so I can find what my 2 different solutions are. The first solution would be negative 4 plus 6, and the second would be negative 4 minus 6. Well, negative 4 plus 6 is a positive 2. Negative 4 minus 6 is a negative 10. So my two solutions are 2 and negative 10. Example 3. Once again, I need to get it in the form x squared minus bx. So I currently have a 12 over here. I need to move it to the other side. So I'm subtracting 12, subtracting 12. Okay. That gives me x squared plus 6x equals 10. Now remember, we're adding some number. That's why I put those spaces there. And that number is b over 2 being squared. B in this case is a, oops, I had a little sign mistake here. Let me fix that. It was x squared minus 6, so I should have a minus there. Okay, so B is a negative 6, so I have negative 6 over 2 being squared. Well, negative 6 over 2, that's a negative 3 squared. A negative number squared is a positive number. What I really have is negative 3 times negative 3, and that is a positive 9. Okay, now I'm going to go ahead and plug that in. So I have x squared minus 6x plus 9 equals 10 plus 9. Rewriting this as a perfect square binomial, I have x minus 3 squared. Because b over 2 was a negative 6 over 2 or a negative 3. So x minus 3 squared equals 19. I have to solve for x, so I'm taking the square root of each side. X minus 3 equals plus or minus the square root of 19. X still isn't by itself. I need to add 3 to each side. So I have 3 plus or minus the square root of 19 because I cannot combine the whole number and the radical. Make sure that I can't simplify this any further. There are no factors of 19 other than 1 that are perfect squares. So my final answer is 3 plus or minus the square root of 19. Example 4 is a little bit different because this time I have a number in front of the x squared term. Now we can't have that. We want it to be in the form x squared plus bx. So what I'm actually going to have to do here is I'm going to have to get rid of that 2 by dividing all the terms by 2. So I'm going to say divide by 2 to get into correct form. Okay. If I divide each term by 2, 2 divided by 2 is 1, so I have 1x squared. That's what I want. Minus 12 divided by 2 is 6x equals, and putting a space here, 14 divided by 2, that would be 7. So now that I have it in the correct form, I can add some number and do completing the square like I normally do. Now that number that I'm adding is b over 2 being squared, so negative 6 over 2 being squared, which is negative 3 squared, which is 9. Plugging that in, x squared minus 6x plus 9 equals 7 plus 9. I can rewrite this as my perfect square binomial, and 7 plus 9 is 16. Using the square root property, I have x minus 3 equals plus or minus 4. Add 3 to each side, I have x equals 3 plus or minus 4. Now remember, I have two different solutions here. One of them is 3 plus 4. The other is 3 minus 4. If I can simplify this, I want to. So I have 7 and negative 1 as my final solutions. Last one, example 5. So the first thing I notice, once again, is I have a 3 here. We want it in the form x squared plus bx, so this should be a 1. Now I'm going to have to divide all the terms by 3. So 3 divided by 3 is 1. I have x squared minus 6 divided by 3 is 2x. And then negative 12 divided by 3, that's a minus 4 equals 0. It still isn't in that form, so I'm going to add 4 to each side. That gives me x squared minus 2x equals 4. I ran out of time, so I finished the problem. Please try it and check to be sure these are the answers that you get.